This is solved problem for a non-deterministic push-down automata. This is one example for construction of non-deterministic PDA. L is equal to A power n, B power m, and C power n. N comma m greater than or equal to 1. If you are seeing the language itself, we can understand here the n is independent but m is dependent. Okay, here the even number of b is followed by even number of c because both are m. Okay, suppose you are assuming n is equal to 1, you are getting this 1a, n is equal to 2, then n is equal to 3, then m is equal to 3. So we can take any value arbitrarily n and m. Okay, so here n is independent, m is dependent. Okay, any number of a's followed by any number of b's, then any number of c's, but equal number of b's and equal number of c's allowed in L. Okay, so here we are going to construct non-deterministic. Non-deterministic means so one input symbol having more than one transition. For example, it will reach more than one state. That's all. That is a subset of state, we can say. Yeah, this is just we are assuming n is equal to 2, then m is equal to 3. We are getting the string 2a, 3b, 3c. Okay. Here, so we have to frame the rules depends upon the problem. So the rules may be changed depends upon the problem only. Okay, so here what we are going to do, suppose we are reading the input A. As per the language, the input is started with A only. If you are reading the input A, no need to process any input in the stack. Okay, just we are moving from starting state to the next state because A is independent. Okay, so if you are seeing B only, how to push the element into the stack. Okay, then move the state. You can change the state also. Then after reading this B over, if you are seeing C, you have to pop the element from the stack. So matches the number of B's as well as number of C. You are going to push the number of B into the stack. The same thing, you are going to pop the number of C element from the stack. That's all. Okay. So here first rule you have to write. What will happen if you are reading A? Okay. Stack symbol is at not possibilities. So you simply move the state. That's all. Okay, no need to push the element into the stack. So why we are saying this non-deterministic? Suppose we are reading Q naught A Z naught, so you simply keep in the same state. The state is Q naught Z naught. Okay, so any possibilities may be, suppose here top of the symbol, if it is A is there, that case we can change the state also. Just move the state only. We can change the state also. Okay, no need to change here. So here for you see here Q naught A, we are getting Q naught as well as the same Q naught, the same input, we are getting the another transition Q1. Okay, so we can't predict, either it may be reaches the Q naught or it may be reaches the Q1. So this is a non-deterministic push down automata. Okay, so like that we have to write the rule. Here Q naught A Z naught may be Q naught the same state, but we can't do anything, simply skipping the input. That's all. Okay, again you are seeing here A, here may be A, again you have to simply skipping the input buffer values control, reads and control. Okay, so here we can differentiate how it is working non-deterministic finite automata based upon this rule only. The same input, it may reach same state, otherwise it may reach another state also, that is a Q1 also. Simply I am writing here Q0 Q0, so you can assume Q1 also. But deterministic push down automata, definitely we have to maintain the Q0 only. Here we can make it Q0 as well as Q1. Okay. So this is way of writing the rules. Okay. So next one is, yeah, if you are reading the next input, again it is A only. You just ignore it, just to move the state as per rule 2. Okay. Then again if you are reading Q0 B, okay, you can push the element into the stack. Yes. So next it may be you can change Q1 also, otherwise the same state you have to maintain, no problem. Yeah, Q0 B, again you have to push the elements into the stack. Then you see here, now we are reaching here, you can change the state also, otherwise you can make the empty. Yes, so you are going to make the empty here as per rule 4. Then again rule 5, still in C, you have to make it empty, so you have to pop the element from the stack. So now you are reaching this end state, so you are going to pop the element from the stack. Now almost we are coming in the end of the buffer. Yeah, this is a way of implementing the transition diagrams. If it is A, is it not the outcome? There is no change, only just to move the state, that is, yeah, same state. Then if you are reading B, you can push the elements into the stack, then change the state, then as it is. If you are reading B here, input is B, stack symbol also B, so we can push the element into the stack. If you are reading the different characters, that is a C, we can pop the element from the stack. Finally it will reach the final state. So as per rule only, first read A, no change. So that's why here saying, here instead of Q0 A, is that not Q0? Here instead of Q0 A, you can use Q1 also. Again you have to start from the Q1. Okay. So in this case, definitely it may be a non-deterministic. If you are making as 1, Q1 here, here, here. Okay. So this is way of writing the rule for non-deterministic finite automata. Here non-deterministic finite automata may be a deterministic finite automata when it is a subset of final state. So the input, the same input have the transition of subset of same state. Okay. So finally we need to ensure whether it is accepted or not. Okay. Initially start with the symbol Q0 A B B C C C Z not. You have to as per the rule only, rule 1 2 3 4. So no change, stack grows, then stack empty. Yes. Okay. Q0 A, is it not? You have to push the element into the stack. Sorry. Suppose you're reading A, nothing. You just move the next state. Okay. Q0 A, ignore it. Then, yeah, come for the next state. Q0 A, B, Z0, you have to push the element to the stack. Again, second B, how to push the element to the stack. Then third B also you have to push the element stack. If you are reading different characters only, how to change the state. Again, Q1C, you have to see the different characters. The C, here B, you have to pop the element to the stack. Then C, B, pop the element to the stack. Then still Q1 epsilon Z0 goes to final state. It may be, the state may be changed. Okay, so this is way of constructing the non-deterministic finite automata. Thank you.